activity. So, but rather than do the manual approach that we did with the graph paper on on Wednesday, we can actually use Excel to solve. And you need in Excel, you need an add-on called Solver. Okay. If you don't have Solver, if it doesn't show up on your ribbon and I'll talk a little bit more about that when we go into Excel, you just need to go to Google and Google, how do I add Solver on my whatever personal computer you have, and it will tell you where to find it and how to do it, okay? So we can use spreadsheets to solve linear programming. Excel has an optimization tool called Solver. If it doesn't appear in your data menu, you likely need to install Solver. One of the funky things is if that you're somebody that needs to install it, once you click on it, you actually have to then click Apply too, at least in Windows. And so sometimes people get frustrated because they go through and they find it and they click on it, but they don't hit the Apply part, which is a kind of an ending step on it. So make sure that you're paying attention to that. But what we do is in Excel, these are the steps we use to solve a linear program. We define what's called the changing cells. And what we mean, sorry, timeout?
One second. All right, cool, you're good.
Okay, what we mean by Excel, or what we mean by Excel, what we mean by the changing cells is what are you solving for, okay? So in our example on Wednesday, we were talking about hockey sticks and chess sets, right? And so the changing cells are going to be how many hockey sticks and how many chess sets are we solving for, okay? And then we have to input into Excel, so it knows what we're doing. We have to input with the objective function, okay? And then we have to input the constraints, which are what's the resource usage. And then we go into Solver and we set it up inside Solver and we run it, okay? And so as we walk through this, so step one, define the changing cells. A convenient starting point is to identify cells to use for decision variables in the problem, okay? In our problem, we were using H for hockey sticks and C for chess sets, okay? Excel refers to them as changing cells. And again, changing cells to me, at first I didn't get the terminology. You just have to adjust to it. All we're saying is what is it that we're solving for, okay? Excel refers to them as changing cells. We have designated, they do B4 as hockey sticks and C4 as chess sets. We'll set it up and run our own. And note that we have set these cells equal to 2 initially. You can set them to anything. Oftentimes I leave them blank. And then after I get all my constraints set up, I'll go back in and I'll put in a 1, and I'll make sure that all my formulas are working right. And I'll set hockey sticks to 0 and chess sets to 1, and I'll take a quick look and make sure all my formulas are working right. Okay? So this is what it looks like. So they have, again, here's my changing cells, right? And I want to maximize, this is my objective function, 2 times the number of hockey sticks plus 4 times the number of chess sets, right? And so that's my objective function. Subject to the constraints, if you remember machine A, we had 120 hours that we could use at machine A. And hockey sticks used 4 hours and chess sets used 6 hours. At machine B, hockey sticks used 2 hours, chess sets used 6 hours, okay? And at machine C, hockey sticks use 0 and chess sets use 1. Sometimes when you move into Connect, students get confused because there's a couple of constraints that come up and it only talks about chess sets. It doesn't say anything about hockey, so it's not really chess sets, it's some vitamin thing, I think, right? And it doesn't say anything about one of the other things. Well, that just means that your coefficient for that is 0, okay? So don't overthink it, right? When you read a problem and it only talks about a machine C or some type of additive and it only mentions one of the products, that means that the other product has a coefficient of 0 for that, okay? So again, here's the changing cells, right? And so then you have to calculate the objective function, which we showed how to do. And we place the profits in cell B5 and D5, and then you have to multiply that. I'm going to walk through this in Excel, so we're just going to read through this so you get the overview. Solver refers to your objective function as the target cell, and it corresponds to whatever as you solve the objective function, it corresponds to whatever that solution is going to be. Okay, so in this example, we're trying to maximize 2H plus 4C, and this is where we're going to have that solution be, and that's our target cell. Okay? And we do the resource usage, meaning that we set up the constraints, and they did this in rows 7, 8, and 9, one for each resource constraint. And again, you just plug in, okay, for Machine Center A, it's 4 hours of processing time and 6 hours for chess sets. For Machine Center, and so then you do that for each of your machine centers, okay? And so these are the steps, so it's maximize this objective function subject to these constraints. Okay? And then we set up solver, all right? And I think it's going to be, I'm going to read through this and then we're just going to go to Excel. Is there a question?
Just the title of step 2, I'm sorry.
Oh, the title of step 2, calculate the total profit.
All right, cool.
Step 3 is set up your constraints. Step 4 is to set up solver. Okay? And then step 5 is going to be to solve. All right? I think it's going to be, I'm going to skip over to Excel and I'm going to show you in Excel.
I just want to get the steps down so I have those for the future.
All right. So here's, and I set it up a little bit different than they do, and you'll see why here in a little bit. And Dr. North actually has this, there's YouTube's recorded of him working a problem out there, and he does it slightly different than I do. So you can do it multiple ways in Excel, you just have to make sure that you're hitting all of those steps as you go along. All right? So, of course, I come out and I say, well, I'm interested in hockey sticks and chess sets, right? So I label it. And then I like to, just for my own clarification, go ahead and put borders around where I'm going to be solving for hockey sticks or chess sets, right? So what I know is that this is what we are solving for, or, as the text says it, the changing cells. And then right below that, I typically do my objective function. Okay, and you can put objective function or objective function coefficients, right? And so for every hockey stick, we said we would get $2 of profit. For every chess set, we said we would get $4 of profit. Okay? And so then this is maybe, how many of you have used some product before in Excel? Yeah? It's an easy way to do this. And so, because what some product does is it's going to take this row times that row, okay? And so, otherwise I'd have to put in, I want to take cell B2 times cell B3 plus cell C2 times cell C3, right? And rather than do that, I can type equals some product, and I can highlight, I want these cells, and then I put comma times these cells. Close my parentheses, okay? And right now I don't have anything in solver, or in those changing cells. So what I do is I plug in a 1. Well, yeah, my profit if I make one hockey stick is $2, right? And my profit if I make one chess set is $4. So what it's doing is it's multiplying the same sequence together and then adding it to the next one. Okay? And I do it, and I set it up this way because then as I do my constraints, I can use some product to calculate my constraints as well. Okay? So we said we needed to come up with our target function, and so that's where we're solving for, where we're going to try to maximize the objective function, and sometimes it's better, you might want to put in maximize here too. Okay? And then I put in my constraints. And I know that we had a constraint for machine A, we had a constraint for machine B, we had a constraint for machine C, and we have non-negativity on all of our linear programming that we're going to do in this class, right? And so that being the case, again, I've got my labels up here, H and C, okay? And on machine A, one hockey stick takes 4 hours, one chess set takes 6 hours. On machine B, one hockey stick takes 2 hours, sometimes with 2, and one chess set takes 6 hours. Okay. On machine C, it takes 0 hours for a hockey stick and 1 hour for a chess set, okay? And so I have to calculate then, given how many I'm going to produce, how many hours am I going to be using on that particular machine. So again, I'm going to do equals sum product, and I'm going to highlight where I have it is B2 to C2, and I'm going to F4 that because I'm going to just want to copy that down, and I want to go back to that reference, okay? And then I'm going to highlight times what I need for machine A and what I need for on hockey sticks and what I need for machine A on chess sets. And I close that parenthesis, okay? And so, again, I'll run through that again. I'm going to do sum product for machine B. How many hockey sticks am I producing and how many chess sets am I producing? Times how many hours for hockey sticks on machine B and how many hours for chess sets on machine B. Close that parenthesis, right? And again, it's the same thing here. How many hockey sticks, how many chess sets am I producing? Okay? And then times how many hours for a hockey stick and how many hours for a chess set. Okay? Here's the thing. Now, if you remember on this very first one, I fixed that cell reference. So I actually could just copy that formula down, and it should work. And again, I test it by putting in, well, if I make one hockey stick, right, that means that I'm going to have 4 hours on machine B and 4 hours on machine A, 2 hours on machine B, and 0 on C. If I make one chess set, right, I'm going to use 6 hours, and 1 hour. So I can just do a quick check to make sure that my formulas are set up correctly, all right? And as we do this, right, so this is what we would call the left-hand side, okay, because that's what we're going to use. And that left-hand side has to be less than or equal to what our constraint is. And our constraint on machine A was 120 hours, right? And so 120 is considered the right-hand side, okay? And on machine B, we need it to be less than or equal to 72 hours. And on machine C, we need it to be less than or equal to 10 hours, okay? You don't have to put in the less than or equal to. I do just to keep me honest, okay? As you get into more complex ones, kind of just keeping track of it as you go is easier than trying to set it up when you get into Solver, okay? So now so if we looked at those steps, let's go back and say, we defined the changing cells, how many hockey sticks and how many chess sets we're going to use. We calculated our total profit by doing the objective function. We set up our constraints, and now we need to go set up Solver, okay? And so what you need to do is go, in my ribbon, it's on Data, and all the way over to the right is Solver. So when I click Solver, the first thing it says, well, set your objective. Well, we know that we want to maximize this cell, right? Because that's calculating our total profit. So I want to maximize that target cell, right? And so I make sure maximize is collected, is checked. Ryan, is there a question?
Where'd the highlighted 4 come from?
Okay, that's because I calculated my profit, right? And so that's our calculated profit. Okay? And so again, I'm coming in here and it's going, okay, well, I want D3 is my target cell. I'm going to click on maximize by changing variable cells, and again, that's why we named them our variable cells or what we're solving for. So I'm going to highlight B2 and C2 because those are the ones that I want Solver to plug in different values for and see where it maximizes the objective, subject to these constraints. So now I need to come into this section and add in a constraint.
Okay, I know you've answered this before because we had to do it to find the data analysis portion. Solver's not popping up on my screen, and I know that there's the little pack that I have to include after that. Can you run through that real quick for anyone that may not have Solver already on their analysis portion?
So how about I finish putting in the constraints?
Yeah, that's what I was saying. Yeah, after that, yeah.
Okay, yep, no problem. That's all right. So I'm going to add a constraint, and so my constraint, I'm going to take the left-hand side, right, and I'm going to say this value, right, when we calculate it based off of how many we're producing, has to be less than or equal to the right-hand side of our constraint, this value. Okay, and I say, okay, well, I need to add another one. And the next one is going to be for machine B, how many total hours we're going to use on machine B has to be less than or equal to how many hours that are available, which is 72. I'm going to put add another one. And for machine C, the total number of hours that we're going to use there has to be less than or equal to the number of hours that we have available, which is 10. Okay? And when I'm done with that, I'm going to say OK. And you'll see those three constraints and are subject to these constraints. Okay? If you remember, I wrote a fourth constraint, which is non-negativity. And we have non-negativity. There's a check mark here. And it says, check this. And it says, make unconstrained variables non-negative. And you just need to make sure that's checked in order to in order to address that constraint. We have several methods that we can use. I'm just going to tell you, click simplex. Okay, that's the method that you want to use is simplex LP. Okay, and I'm going to go solve. So this is the last step to say solve. Okay, and if you'll note, it comes back with what we came up with when we solved it by hand, right? 24 and 4. That was our ideal solution, what we found in class on Wednesday. Okay. There are other reports that, and one of the ones that you need to probably click on because you may have some questions to answer based on this sensitivity report. So once you solve it, you have these options. Do you want to keep the solver solution? Well, yeah, okay. Do I want any reports? I want the sensitivity report, and when I click OK, it's going to create a sensitivity report over here on this other tab. Okay? So that's a pretty straightforward, we're maximizing profit, okay? And we have three constraints that we're entering into solver, and you just need to, I think that some people set them up differently. I set them up in this format because I like to use some product when I'm when I'm doing my math. And so I just keep everything for hockey sticks in one column, everything for chess sets in one column, and then I do the calculations off to the right of that. And that's the calculations are what you then input into solver, right, where those cells are at. Okay? All right. So you're saying where is that located at?
Yeah, went into options, went into add-ins. I just need to know which one to run.
So if I go options, add-ins,
If you
I
don't,
do analysis tool pack.
Okay.
Wait, I think if you scroll down, I think it's analysis tool pack. Go. And you see solver add-in comes up.
Yep.
Okay. And then I say okay.
Yeah, it's just taking a second. Yep.
Yeah,
there it is. Cool. Now,
Sometimes it doesn't go to that second screen, and so if you're on an older version, then instead of going to the second screen to click it, there's an actual, then you have to click apply. There's like in the bottom of that window, there's an apply button, and you have to hit that for it to go.
so not to beat a broken record, but did anyone else not have solver while we were going through that?
Did you get it now, Ryan?
yeah,
You're getting it?
Okay.
You want me to walk through it again?
Yeah, because I don't know how to do it, and I kind of want to.
Well, I kind of want you to, so that works out well.
I just didn't want to bother everyone else who just listened to the whole thing.
Well, no, that's okay. What I'll do is I'll just start a fresh tab. Would you like me to do just another simple problem, maybe a different one, or do you want me to just do this exact one that we've been working on?
Whatever you want to do. I just want to run through it and make sure I know how to do it.
Okay. All right. So I always start out by identifying what I'm trying to solve for, right? And we're trying to solve for hockey sticks, how many hockey sticks we're going to produce, and how many chess sets we're going to produce, okay? And so I just can't hardly stand to not have that centered, so I go ahead and center it, right? And then to make myself be aware, I put, okay, I'm going to put borders around those that we're solving for, because then when I go to use solver, I know exactly which ones I'm saying, okay, that's what I'm using, okay? And the next thing that I do is I put in, our objective function is to maximize the objective function, right? And in order to do that, I have to know how much profit from our problem, And we said that we got $2 profit for every hockey stick and $4 from every chess set. Okay? That being said, I need to identify my target cell. So and my target cell is going to be, well, somebody help me. What is my target cell? What am I going to do?
At that certain level. But you're going to do some product.
I'm going to do some product.
B2, C2, comma, B3, C3. Close parentheses.
Yep. Okay.
Highlight.
All right. And then I'm going to enter my constraints because I need to solve that problem subject to these following things.
Okay.
And so I know from my problem that we have 3 machines that we have constraints on, machine A, machine B, and machine C. And I always know that I need non-negativity.
Right.
Non-negativity. Okay? And so I know from the problem that for machine A, hockey sticks require 4 hours. Chess sets require 6 hours. Machine B, hockey sticks require 2 hours. Chess sets require 6 hours. Machine C, hockey sticks require 0 hours, and chess sets require 1 hour.
Right.
Okay? And I just put in my equal sign here because well, partly because I'm teaching, because I think it helps you see what we're trying to accomplish. And I'm trying to come up with my left-hand side constraint. How many hours, the left-hand side constraint basically means how many hours of that machine are you going to use subject to what we've solved for. Okay? So my left-hand side of the constraint is going to be the sum product of how many I'm going to produce of hockey sticks and chess sets multiplied by how many hours hockey sticks take and how many hours chess sets take. Okay? And again, I F4'd that fixed cell reference up on how many hockey sticks and how many chess sets. Okay? And again, I typically like to come back at this point and go, okay, well, if I produce 1 hockey stick, I'm going to have $2 of profit. I'm going to use 4 hours and 2 hours and 0 hours. That all makes sense. If I produce 1 chess set, I'm going to make $4 of profit. I'm going to use 6 hours, and 1 hour, right? And so that way I just have made sure there's no silly errors in my formulas. And then those constraints, of course, it's not enough just that we solve for how many, but the subject to is what's the maximum amount of hours that we have available here. And that's our right-hand side. Okay? So we have 120 hours of machine A, 72 hours of machine B, and 10 hours of machine C. Okay? All right. Everybody with me to that point? Okay, you guys with me to that point?
Yeah, I'm good to that point, yeah.
Okay, so now I'm going to go solver, and I'm going to go data, and all the way on the right-hand side, I have solver.
Now I have it, cool.
Okay, so now I'm going to go, my objective function is my target cell. What are we trying, the profit that we're trying to maximize.
Okay.
So I click that cell and come back to solver, and I say we're maximizing that, so I make sure that maximize is selected. And I say, and we're going to do that by changing cells B2 and C2, right? Those are the 2 that we've got highlighted and that we've used in all of our formulas.
Right.
And then I'm going to go subject to these constraints. And so then I have to add my constraints. And basically you're adding in the left-hand side in the first cell reference has to be less than or equal to the right-hand side of 120. And then I add another one.
That was what I did for you.
Okay? And now I'm going to say for machine B, the left-hand side, which we currently have calculated at 0, has to be less than or equal to the constraint or the right-hand side of 72. And I have to add another one for machine C. The left-hand side of 0 has to be less than or equal to the right-hand side of 10. And I'm done with that. I need to make sure I have non-negativity. And I want to click the method to solve. I want to use simplex LP. I'm going to solve, keep solver solution, and I want the sensitivity report. So then we're going to go OK.
So for sensitivity report, you click outline reports? Or is that a separate? Never mind, we're good.
Did you get it?
Yeah.
Okay. All right. So that's how we solve the basic problem. But now let's take a look at this sensitivity report and talk through what it tells us. So it gives us some information about the variable cells and some information about the constraints, okay? And so what it does, first off, it tells you your final value was 24 and 4, okay? And then it tells you what range could you actually not change your area that we drew. What range in terms of solution could you change things to and not change that optimal solution? And so basically what you're saying is, I could increase hockey sticks to 24.67, right? And decrease them by 0.67. So my range for hockey sticks is going to be 23.33 to 24.67, and that would not change my optimal solution, okay? Anything outside of that, if I said, well, can I use this information if I want to produce 25 hockey sticks? And the answer is no, because now the optimal solution has changed and you need to rerun it, okay? So, and then we've got machine center A, machine center B, machine center C, gives us the final values here. So, question is, if our final values are 120, 72, and 4, are we using all of the available hours on every machine center? No, we're not using them all for C, right? And we are actually short. So what was the maximum that we could use on C?
10.
And how many did we actually use?
4.
So what's the slack there?
6.
6, right? So this information can tell you, and what happens is, if you haven't used all of the available hours, you don't have what's called a shadow price, okay? And a shadow price is basically, if I added one more hour of that constraint, how would it affect my objective function? So I could come back to this and say, if I added one more hour of machine center A, I would increase my objective function by 0.33, okay? As long as it wasn't outside of the allowable increase or allowable decrease, okay? And so for this machine center A, I could increase this up to 144 hours, or decrease it, what's 120 minus 36? 84? So the range here is going to be 84 to 144, and my solution never changes. But as soon as we say, well, what if we had 150 hours? Then I have to say, well, we have to resolve, because that's outside of our allowable increase or allowable decrease, okay? So that's, again, this kind of gets into your sensitivity report that you're due for your next homework too, but you've got a question on this in part B. So you want to make sure, are you tracking with me on what these are telling us? Okay. Understand the top part deals with your objective function, and this bottom part deals with your constraints, okay? And it's giving you allowable ranges, right? And for this, it's telling you the impact of if you added a unit, how would that affect your objective function, right? So that question would come up, if I could add one more hour on machine center A for 0.25, 25 cents, would I do it? So if I could add, the cost to add an hour on machine center A was going to cost me 25 cents. Would I do it?
Yes,
And why would I do it?
because you were saying you get a 50-cent increase.
A 0.33
Oh,
increase. Yeah.
0.33, yeah.
Yep, so I get a 0.3, so the answer would be yes. If I said it was going to cost me 50 cents an hour to add one more hour, would I do it? I wouldn't, because I would not gain as much by doing that. Okay?
Unless you can get a tax write-off, but
Okay.
that's not this class.
Yeah, that's not this class.
So I guess it didn't click where that 50 cents and that 50 cents extra is coming from, because I understand the 0.33, but
Okay. So let's just say, so the question would become, there's a cost
this is theoretical. This hasn't been like discussed like already from the problem.
Right.
Oh, okay, cool.
Yeah,
Never mind.
yeah,
All
yeah,
right,
this
cool.
is theoretical. So
Okay.
it's just saying, would you, if the cost of that resource was going to be 50 cents an hour, or
Right.
50 cents for that one more unit of resource,
Right.
1 hour of that,
So 50 cents for 72 to 120, or for 4 to 72. I guess 50 cents from where's our production point? Where
Okay.
can we see our production point?
so right now, we're producing 24 and
Right.
4,
Okay.
okay?
Cool.
And we can, again, again, increase production up to 24.67 and decrease production down to 23.33, and this solution is valid for that,
Okay,
okay? Theoretically, if we're talking about the constraints then,
right,
and we're saying that, that for every hour that I can add to this, or every hour that I subtract from this, I'm
Right.
gonna affect my objective function by basically 33 cents, okay? So let's go take a look at that real quick.
okay,
So if I come back over to here, and so I'm just gonna say a prayer that this works like I think it should, and I decrease that by 119, I think if I resolve it, it should decrease our objective function by 33 cents. It changed the solution. Let me think about that for a second. It shouldn't have changed the solution because we were inside.
it's still trying to do, I think it's still trying to do the original formula though.
Oh, never mind. You know why? Because I put that in the wrong spot. Because I changed here instead of here. Change my right-hand side constraint. I messed up the formula.
Yeah, I ran it, it's right. If
Yeah.
you move, if you just strictly move right-hand
If I
side
move
down
that
there.
right-hand side constraint down,
Yeah.
you see it took our objective function down by 33 cents, right? And that's what that report is telling us.
Okay,
what it-
cool,
what
cool,
is-
cool.
How that works. And so you can play with that a little bit if you're getting into, and the other thing I would encourage you to do is when you're working on your Connect homework, open up the Connect practice session. I think that will help you to look at how they're working their way through it as well, okay? I will be around on Monday, so if you have questions and you want to come out to the office, you're more than welcome to do that. I've got that space outside my office for people to work if you want to. You don't have to, and let's see.
Space outside of
I think
office
we're pretty good here on time. Do you feel like, we ran through that a couple of times, do you feel like you've got an okay idea? Okay, I'm gonna put the recording out there as well, so if you need to go back and you can kind of look back through the recording. Any questions before I let you go? No? All right, hey, everybody have a happy turkey day if I don't see you.
Gobble, gobble.
Gobble, gobble.
Dude, I'm pretty sure that the other night when we ate like a course or two and a half.